Ham class, we're gonna move into sequences now. And the first kind of sequence we gotta learn about is an arithmetic sequence. And then the second one will be a geometric sequence. Marco is building towers out of dominoes. He uses a pattern to determine the number of dominoes to use at each level. So you can see the dominoes he's stacking right here. Use the tower illustration to complete the table for levels 1 through 3 and answer A through C. So on levels 1, 2, and 3, and 4, how many dominoes did he stack up? Well, we can see level 1, there is 4 of them. And level 2, he's got 7 of them stacked up. Level 3, he's got 10. And then level 4, how much would he stack for level 4? Do you see the pattern that's emerging here? Okay, it looks like we're just increasing by 3 every time. So we would have 13 dominoes for level 14. So for A, write the number of dominoes used at each level as a list. So we got 4, we got 7, we got 10, and we got 13. Just like we have in the table, right? So now, describe the pattern Marco is using to determine the number of dominoes needed at each level. So Marco adds 3 dominoes on each level. Complete the table for level 4 and sketch the tower Marco should build. Complete the table. Okay, so we completed the table already. Now we gotta sketch the little tower. So it would look something like this. Okay, so we got the tower, we got the table, and we got the list. The number of dominoes at each level forms a sequence or an ordered list of numbers. So there's definitely an order to these numbers here. They just keep increasing by 3. Each number in the sequence is called a term. The nth term in a sequence can be written using either subscript notation or function notation. Subscript, of course, is when you have a small term or a small variable or number written below, so it's subscript. Or we can use function notation, which we see right here. So in subscript notation, A sub n is the term, n is the term number. So A is the term and n is the term number. In function notation, f of n is the term, n is the term number. So 2 different ways to write the same thing. Using the domino example, answer questions 1 through 3. What are the first 3 terms in the sequence? So in the domino example, the first term is 4. The second term is, let me scoot my paper down here. The second term is 7. And A sub 3, the third term is 10. Okay, what is the value of f of 4? So in other words, what's the value of the 4th term? The 4th term is 13. Without sketching a model, could you find the value of A sub 5? So if we went up 5 levels, how many dominoes would there be? We just add 3 to what we had in level 4. So yes, we add 3 to the dominoes in level 4. And that would be 16. Okay, so more vocabulary here. An arithmetic sequence is a type of sequence that follows a particular pattern as described below. A sequence where the difference between consecutive terms is constant. The difference between consecutive terms is constant. This constant difference between terms is called the common difference. So the common difference in this case with the tower was 3. Is the domino sequence an arithmetic sequence? Why or why not? So this definitely is. Yes, because the difference between terms is constant. The difference between terms is constant. Okay, in this case, the difference was 3. Okay, it was 3 every single time. So let's flip over to the back portion. Number 4, determine if each sequence in the table is arithmetic. If so, record the common difference. Okay, number 5, explain how you could find future terms in the arithmetic sequences. Okay, let's just stick to the first part here. So this sequence right here, 3, 5, 7, 9, 11, and 13, is that an arithmetic sequence? Do you see a pattern where they just keep adding the same number? Looks like they just keep adding 2 over and over. So yes, this is an arithmetic sequence. What's the common difference? Meaning, how much did they increase from term to term? They increased by 2. And this sequence right here, we go from 50 to 42 to 34 to 26. Yes, this is an arithmetic sequence because what did they keep adding to each term? They added a -8. And this one right here, from 3 to 6 to 12 to 24 to 48. No, this is not an arithmetic sequence. That's a sequence, but it's not arithmetic. Okay, they can't just keep adding the same number here because first they added a 3, then they added a 6, then they added a 12, then they added 24, and so on. So from 15 to 20 to 15 to 20, nope, not an arithmetic sequence. They're not adding the same number. From 31 to 27 to 23 to 19, I'll let you fill in the answer there. I got to give you something to do. Explain how you can find future terms in the arithmetic sequences. Keep adding the common difference. If a sub n represents a term, how could you represent the term before a sub n? We use a sub n minus 1. Okay? The term before is always going to be n, or a sub n minus 1, excuse me. So we just have to subtract 1 from that sub term, from the, what's the term we used here? And we call it a term number. So just take away 1 from the term number and we could go to the term which was before, okay, the previous term. One of the ways to represent an arithmetic sequence is by using a recursive formula. So this is just one more way to write the sequence. A recursive formula will define a starting term as a sub 1. That's the starting term, it's the first term, right? This 1 represents the first term, as well as a process for finding the nth term of the sequence using the previous term. Label the parts of the formulas shown. So this right here is the previous term, like I mentioned. Previous term. And this right here is the common difference. Okay, so looking at function notation, it's another way to write it. This is the previous term. And this is called the common difference, D. A recursive formula for arithmetic sequence is shown at the right. In your own words, describe what the formula means. Then write the first 5 terms of the sequence. Okay. I'm looking at this here. A sub 1 equals 11. So the previous term for a sub 1 would be this here. Okay. So if the first term is 11 and we keep adding 6 to that, we're going to go 11, 17, 23, 29, 35, and so on. Okay, that's the first 5 terms because we just kept adding 6. And the very first term was a sub 1 equals 11. So 11 was our first term. We kept adding 6 each time. Okay, so how do we explain this in our own words? I'll give it a shot here. A sub 1 is the first term. And we continue to add 6 to the previous term. Okay, so let me just at least do one more example with you. Number 7, a sequence is generated using a sub n equals a sub n minus 1 plus 7, where a sub 1 equals 10. Write the first 4 terms of the sequence. So if we know that the first term is 10, and we just add 7 to each one, we're just going to have 10, 17, 24, and 31. Okay, they asked for the first 4 terms, and that's all it is for arithmetic sequences, right? So just keep using the common difference to keep adding to each term and generating your sequence. Okay, that's it for arithmetic. We'll move on to geometric formulas as the finale. Thank you.